Okay, so here we're going to be starting where we're still going to be doing hypothesis testing in Chapter 9, but our focus is going to be on comparing two different samples. You know, when you have two different samples and you look at the average of each of those samples, sometimes when we look at those averages, they look pretty similar, or other times they look like they're not the same at all. But just because the samples produced means that we're different doesn't mean that we believe the population mean to be different. To really say that two samples come from populations that have different means, we need strong statistical evidence. When we compare two groups, researchers often want to determine if the mean of one group is significantly different than the mean of another group. Some examples, really like the lifetime of two brands of tires, but that's the lifetime of two batteries, lifetime of two different brands of something. Whenever we want to compare different brands or different varieties of something and see is there one significant difference, is there a statistically significant difference between one and the other. Things like average age of college students enrolling in community college versus a university. All right, when we have the sample mean and the population standard deviation for each group, we can run a z-test. When we run the z-test for a two-sample test, we're going to select a two-sample z-test on our calculator. But we do still have to have the population standard deviation. If we don't know sigma for both of them, we can't run a z-test. But if we do, the z-test is the best test for us to run, so we will always defer to that. Our null hypothesis is going to be that there is no difference, that mu1, that the mean of the first group is equal to the mean of the second group. In the alternative hypothesis, there will be three choices. It always starts with mu1. We could say mu1 does not equal mu2. We could say mu1 is less than mu2, or we could say that mu1 is greater than mu2. It's super important that we identify early in the process what's mu1 and what's mu2. Which group does each belong to? Because if you're saying, based on the way the question's worded, that mu1 is less than mu2, but you put the data in backwards in your calculator because you can't keep track of what's group 1 and what's group 2, you're going to get yourself into some trouble. All right, let's take a look at, and we're going to use the p-value method here. So let's take a look at how to do that in our calculator and how to run the p-value method. All right, so a survey found that the average hotel room rate in New Orleans is $88.42. So let's go ahead and let's start identifying New Orleans and then compared to Phoenix. So I'm going to do New Orleans compared to Phoenix, oops, PX. Okay. It says that the average room rate was $88.42, so that'd be X bar 1. My first sample mean was $88.42. And the average room rate in Phoenix, so X bar 2, would be $80.61. Assume that the data were obtained from two samples of 50 hotels each. So the sample size for the first one is 50, and the sample size for the second one was 50. Those do not have to match. They often don't. And that the standard deviations of the populations, so that means sigma 1 and sigma 2, were 562 and 483 respectively. So 562 and 483. At alpha equals 0.05, can it be concluded there's a significant difference in the rates? All right, so let's start with our null hypothesis. Mu1 equals mu2. Now I'm referring to mu1 being New Orleans, that's why it's in the group 1, and mu2 is being Phoenix. Okay. The alternative hypothesis is that mu1 is what to mu2? We want to say that there's a significant difference in the rates. So we're just saying not the same. And if we want to conclude that there's a significant difference, then we need the claim to be that alternate. The next thing we need to do is use our calculator to find the z-value for our test statistic and the p-value for our comparison to alpha 0.05. So we can make a decision to reject or not reject. I'm going to grab my calculator. stat, go to tests, and right there is a 2-sample z-test for option 3. We'll do statistics. I've got a standard deviation of the first is 5.62. The standard deviation of the second is 4.83. Okay. X bar for 1 was 88.42 and N1 was 50. N2 was 80.61 and N2 was 50. We want not equal to, and we'll say calculate. My z-score is 7.45. 7.45, and my p-value, this was really tiny, is 9.24 e negative 14. 9.2 e negative 14. 9.2. Remember, when we get that e negative 14, that means it's really, really tiny. Scientifically, this is scientific notation, so that's extremely small. That is less than alpha. Whenever the p-value is smaller than alpha, we reject H naught, and we can say there is enough evidence to support the claim. Okay, so what we're saying is that these are not equal to each other. Okay, this is really important for the next stage of what we're going to learn how to do. We're going to learn how to build a confidence interval. So using this p-value method, it works really well. But if you don't quite understand or you can't keep track, another way to look at this is, what is the implication of mu1 equaling mu2? Well, if I took mu1 and I subtracted mu2, if they are equal, then this would equal 0, correct? All right, if they're the same, then subtracting one from the other would give a 0. That doesn't apply to this specific process, but it does apply to the confidence intervals. And while we can use the confidence interval to test the null hypothesis. Here's the basic premise. I'm not going to do this calculation. I'm going to use my calculator to do it, but this mu1 minus mu2 in the middle is really important. We're going to do the same thing that we just ran, the same data set, but we're going to do mu1 minus mu2 in the middle of a confidence interval that's 95%. Remember, if alpha is 0.05, then we have a 95% bubble in the middle. So this is the equivalent of doing the alpha at 0.05. I'm going to choose to run a confidence interval instead, and watch what happens as we do that. It is a 2-sample z interval, which is option 9. The data copied over for me, which is really nice. I want a 0.95 confidence level, and if I calculate, I get 5.756 up to 9.864. All right, so whatever the case is, remember this is New Orleans and this is Phoenix. What this data tells me is that when I take the New Orleans mean and I subtract the Phoenix average, right? So I subtract those two averages. The difference in them is somewhere between $5.75 and $9.86. But what's really important is that that cannot equal 0. 0 does not fit between those numbers. The implication is that thus mu1 cannot equal mu2. There is no way that they could be equal to each other. So that would tell me I have to reject the null hypothesis. So rather than using the p-value method every time, we can also use the confidence interval to tell us if it's possible or statistically reasonable for us to believe that they're equal. If they're equal, if they were actually equal to each other, then this number here would have to be negative and this number here would have to be positive, so that 0 could fit between them. But as it currently stands with this confidence interval, I can say with 95% confidence that they are not equal in value. All right, good luck, guys. That's it. Good luck. We'll see you in class.